Hi everyone. In today's challenge we have this problem. The problem is minimum flips to make A or B equal to C. And the problem number is 1318. Alright guys, so first of all we are going to clearly understand this problem statement. After that we are going to move to the logic part. We are going to see how we can solve this problem. And after that we are going to move to the implementation part. We are going to implement our logic in C++, Java and Python programming language. Fine guys, now let's see what this problem say, right? So problem say given three positive number A, B and C. Fine. Return the minimum flips required in sum of bits A and B to make A or B equal to C bitwise OR operation. So first of all, OR here means the bit we can say if you have learned about bit things like we have OR operator, AND operator, NOT operator, XOR operator, XNOR operator. Right? These are nothing but bitwise, right? Bitwise operator. So here we are going to say that we are given with three numbers A, B and C, right? And all these numbers are going to be positive. None of them is going to be negative, right? So let's say this is A, this is B and this is C. Now what they told us that we have to do A or B. Means we have to do the OR operator between A and B. Means we have to perform OR operation between A and B and that result should be equal to C. Means whatever the result we are going to get, let's say 101. So that value should be equal to C, right? But right now what we have, we don't have that particular value in this A and B which can give us the same result as C while doing the OR operator, right? So they have told us that we have to flip some bit. So let's say A have 100 and B have 110, right? Now the C have 101. So guys, here what we need to do OR operator of this, right? If we are going to do OR operation, so first of all let me tell you what is OR, right? OR says that whenever a bit of, let's say whenever a bit here you can see 00, so it's going to be 0 always, right? If both bit are 0, so the result is going to be nothing but 0. But if any of the bit, if here we are getting 1 or here we are getting 1 or both side we are getting 1, then the result is going to be 1. So here you can see here we have 1, so we are going to say 1, and here both are bits, both bits are 1, so we are going to say 1, right? So here you can see our answer is 110, which is not matching with C, right? But we have to match with this, right? So what we can do, we can flip some bit. And how we can flip? So here if I say this one to be 0 and this one to be 1, right? So let me do undo this one to be 1. So if I now calculate my OR operation between these two A and B, so here you can see we have 1, so it's going to be nothing but 1, right? Here we don't have 1 on both any of the sides, so we are going to say 0. Here we have 1, we are going to say 1. So now you can see that this is nothing but matching with our C, right? So the minimum flips we require is nothing but we can say 2. We have changed this 0 to 1 and change this 1 to 0. I hope you are getting guys, right? So that was the simple problem statement, right? So now let's see the example. And before that, let's read this line as well. Flip operation consists of any single bit 1 to 0 or change the bit from 0 to 1 in their respective presentation. So basically simple meaning they have told that they have told us the meaning of flipping a bit. Flipping a bit means you can flip 0 to 1 or 1 to 0, right? Nothing big in this particular line. So now let's see the example 1. In example 1 we have A2, B6 and C5, right? So let's remove all these things. And this is a very interesting problem guys, right? We don't need to write a much code, like not more than 10 line of code here. So A is nothing but 2, right? So we can say binary representation of 2 is nothing but this, and B is 6, right? So B is 6. So binary representation of 6 is nothing but 110, right? And C is nothing but we could say 5. So 5 we can say, right, 101. Now guys, if we are going to do right now OR operation, so what we are going to get 0, 1, 1, 1 and here 1. So we are getting nothing but this particular thing, right? But we don't want this, we want this 5, right? I hope you are getting this. We are getting a 6 but we want this. So see here the result are not matching. So we have to flip some bit. So how we can flip, and which bit should we flip? So focus over here. If we need here what? We need 1, right? So you can see we need 1, so they have flipped this particular bit, right? They make it 1. Alright, so now the result is going to be nothing but 101, right? But here they need a 0, so right? So they need to convert both bit to 0. Now if you will do the OR operation, so it's going to return 0. Now here they need 1 only and we are getting 1 only, so we don't need to change anything on this particular side. So we are getting a same output now, right, with the same, and we have flipped 2 bit, not 2, 3 bit, right? So this one and this one. So we are going to return answer 3, and here also you can see that in output we have 3. I hope guys now you understood how this 3 came, right? So by this example, I hope now you understood the problem statement first of all, right? You have a clear idea what we have to do and what are the inputs we are given with and what are their role, right? So now let's move to the logic part and see how we can solve this problem. And logic is gonna be really interesting, guys, because it is not more than a brute force approach, but we are gonna use it in a better way by using a bit operation. So guys, first of all, what we are gonna see that any of the number, let's say number is given 6, B is given let's say 5, and C is nothing but we can say 8, right? Now if you are going to do anything, so first of all, if you will see binary operation of 6, so what you are going to get, you are going to 1 0, and here also you can say 1 1 0, right? This is nothing but 6. And for B you are getting a 5 is nothing but like this, and C is nothing but you can say 1 triple 0. So this is nothing but you can say binary, we can say binary conversion of all this number. Now what we need to do, we need to traverse from the left to right, right? We are going to traverse from left to right and from here as well, right? Right. Now once we are traversing for 0, we are going to check it, what is the we can say the value of this particular index, or we can say what is this one or not, right? If we are going to say the first bit, we are going to traverse from 0 to 32 side, because at max there going to be a length of 32. So we're going to traverse from that 0 to 32, and we're going to check all the bit, right? So for first time we're going to say tell me the C is 1 or not. So you can see the 0th bit, this is 0th bit, so C is nothing but 0, right? And tell me the B, A is also 0, and B also, and B is 1, what, right? So now we are going to do some operation here, and what are these operations? We are going to say, first of all, if C is 0, then both bits should be 0, right? Right. So here you can say this is not 0, B is 1. So we are going to say our result, or we can say our flip should be equal to plus equal to A plus B, right? If C is 0, if C is 0, that means none of the bits should be we can say 1, right? Both should be 0, right? So we can say flip should be equal to A plus B, whatever the value of A. Fine. So here you can see flip is going to be nothing but equal to, like, let me take a different color. So flip is nothing but we can say equal to 1. All right, now let's move ahead. We are going to move to the first index. So here in first index, if you will see that C is again 0, and A is 1, and B is also B 0 is this time also. So here you can see if C 0, A and B should be equal to 0, right? But here A is 1, so we are going to add this bit as well in our flip. Flip is going to be equal to 2. This is the same case as earlier, right? All right, so now let's move ahead. Okay, here again C is 0, A is 1, and B is also 1, right? Again C 0, that means both bits should be equal to 0. So we are going to say flip should be equal to the sum of this A plus B. This is nothing but this time 2. So 2 plus 2 is equal to 4, right? All right, so go ahead. Now guys, we are going to say C is 1 and A is 0 because there is no more bit, right? And B is also 0 because there is no more bit there. So we are going to take 0 only, right? After that, now once we are done, here we can see we are getting C1. That means there should be at least one bit on the A or B side, right? So we are going to check it. First of all, here the condition is going to change. If C is 1, then we are going to say if C is 1, then if A plus B is less than 1, if A plus B is less than 1, that means both bit are 0, then we are going to add 1 in our flip, right? So we are going to say add in our flip, that means flip is going to be equal to 5. So for this we are getting answer 5 because C is over, right? So it will go until we can say till 32, but every time it is going to give 0 0, right? C is also going to be 0 because there is no more bit left. A is also 0, B is also 0, right? So that is the simple questions. We are getting answer 5, and here also you can see that if you will flip some bits, so you will get answer 5 only, right? So let me tell you what will flip you have to do. So we need to make a 0 0. So we are going to convert it into 0, but we can say 1 bit change, right? So we again done this. We are going to also make it 0. Second chain. All right. So we are going to make this as 0. Third chain, and we are going to write here one more extra bit, that is 1. So it is going to be fifth chain, right? So we have flipped 5 times to make our answer equal to C. So that's the simple operation, guys, right? And simple logic. I hope you got understood this particular part. And what we are doing, actually we are moving from left to right, means from 0 to 32. And zooming, guys, here if you can see that here only 3 bit are there, right? 4 bit, but here are 0 0 0 ahead of it, right? So we are not showing that thing, but it is right there. Now the main logic also come, that how will you know that whether that bit is 0 or no, right? Or that bit is 1 or no. So let's say A is equal to 1 2, or let's make it 1 1 0. So now guys, how will you come to know whether this bit is 0 or 1, right? If you're traversing over there, you need to check whether this is 0 or not, right? On A, B, and C both sides. So for that, we are going to use a set thing. So here what we are going to do, we are going to say, okay, if we need to find the first bit, if it is 0 or 1, so we can say, All right, so you can do like this. So which is nothing but equal to tell us that what should give us the bit here as 1, right? So if we are going to do, we are going to get the answer 10, right? So we are going to simply make an AND operator with this particular bit 10. And for this, if the answer is coming 0, here you can see the answer is coming 0, so that means that bit is 0. If answer is coming 1, that means that bit is 1. For example, if we are going to say check that this bit is 1 or not, so we're going to just do the AND operator with this, and we're going to see that 0 0, here answer is 1 0, right? So here answer is not 0, right? If answer is not 0, then you can say this bit is 1. If answer is 0, then you can say it, this bit is also 0, right? So we are going to see everything in the code. Don't worry about this part if you are not getting anything, but with the code part you will definitely going to understand each and every part. So let's move to the code part and see how we can implement this particular logic in C++, Java and Python, right? So let's open this particular browser. And here guys, first of all I'm with Python. So first of all, what I'm going to do, I'm going to see my result, which is going to be nothing but equal to 0 initially. And see guys, first of all we are going to traverse from 0 to, for I in range from 0 to until what, till 32, right? So at max you can see here also we have a race condition a will not exceed more than 10 is to 9, right? So a will be not more than 10 is to 9 number. So we can say for I range of 32, we can say here fine. Here we need to check what is the value of c. So we can say first, second and third, right? They are initially 0, right? First telling us that the set bit of a, and second would be third for c, right? So all are 0, right? Initially all are 0, means I have told that everyone have a 0 bit, right? So here we are going to check it. If a more, first of all we are going to do that particular operations I great 1, we are going to multiply with I, and this thing is going to tell us that whether that bit is 1 or not, right? If it this bit, if we are going to going this operation and that operation is telling us not giving us answer 0, right? That means that bit is 1, right? So that means we can say that bit is 1, so we can make it first is equal to 1, right? Otherwise it is 0 already, right? If it is not equal to that, so we have make by default them 0, right? Same thing we are going to do for b and c as well, right? So let's copy this part and let's paste it here. Let's paste it here. So here we are going to do for b, c for b, right? If b is not equal to 0, then we can say second is 1. For c we can say third is 1. So by this we have checked that on that particular index, on that particular we can say position, what is the a bit, what is the sign of b bit, what is the sign of c bit, right? If they are 1 or no. So this we are going to get it now. Now we are going to check if third means if c is equal to 0, that means we have to add both things, right? We can say result plus equal to first plus second, we have seen already, right? But if it is not equal to that, then what we are going to do, we are going to say any of the bits should be equal to if third is 1, that means any of the bits should be equal to 1, right? At least 1. So we are going to check if first plus second is less than 1, means none of the bit is equal to 1, so we can say result plus equal to 1. Once this is done, we are going to return our result. Let's run this code and see whether it's working fine or no. All right, and here we got an error that is nothing but okay. All right, I'm using a Python and I'm using a curly braces. Fine, that's amazing, isn't it? What happened to me? I don't know. Let's run this code. And here you can see that all the test case passed. So let's try to submit this code as well. And I hope it will also get submitted, right? And here we go, guys, right? We have successfully submitted with this. Now let's move to the next programming language, that is nothing but we could say C++. And quickly we are going to make a result variable, which initially going to be nothing but 0. We don't need to flip anything right now. We can traverse over for 0, I less than 32, I plus plus. And here what we can do, we can say initially make all this first is equal to 0, second is equal to 0, and third is equal to 0. If they are 1, we are going to make it change later. Here we can say for a part, for a we can say and 1 here I, if this thing, if this expression is not equal to 0, that means a the we can say the 8th bit is nothing, ith bit of a is going to be nothing but equal to 1, right? So we can say this is first is equal to 1, and same thing we are going to repeat for b, for c, right? So we can say here going to be nothing but third, here going to be nothing but second, here we can say b, here we can say c, right? Once this is done, we are going to say if third is equal to 1, means the ith bit of c is equal to 1. Let me what I am doing, right? If it is 1, then we have to do something, right? But if it is 0, Then what we are going to do? We're going to say simply, if it is 0, that means a ith bit of a and b should also be equal to 0, right? If they are 1, so let's add in result. We have to flip them. Result plus equal to first plus second. Fine. Else we what we are going to do? We are going to say that means third bit is 1, right? Third is 1. That means ith bit of c is 1. So what we are going to do? We are going to say none of the bits should be 1, right? Of ith bit of a and ith bit of b should not be equal to 1, right? So we are going to say if first plus second is less than 1. I have told you something wrong, like ith bit of a and ith bit of b, any of the bits should be equal to 1. At least one bit should be equal to 1. Then only we can make third equal to 1, right? If any of the bit is not equal to 1, means both bits are 0, then we can say simply result plus equal to 1, right? After that we can simply return our result. Now let's run this code this as well, and I hope this also got submitted. And here you can see test cases are passing, so let's try to submit this as well. And it also got submitted, right? Now let's move to the last programming language, that is nothing but Java, to create defining our result variable, which is nothing but 0 initially. And here we are going to say for int I0 I less than 32 I plus if I not I, first of all define three variable. First, which is telling us the ith bit of a, which is initially 0. Second, ith bit of b, which is initially 0. Third, ith bit of c, right, which is also 0. Now once this is done, we are going to say if a, not, let me make first bracket a more, we can say and, we have to do and I, or we can say 1 here I, right? So what we are doing a right shift of I, right? Okay, now once this is done, we are going to say if it is not equal to 0, then we can say first is equal to 1, right? And so we are going to copy this particular thing again, and here paste it, and here also paste it, right? Now once this is done, we are going to make it third, we are going to make it second, and here we are going to make it b, and here c, right? Once this is done, once we have got it now whether the ith bit of a is 1 or not, ith bit of b is 1 or not, ith bit of c is 1 or not, right? Now we are going to check it if third is equal to 1, or first of all let's check it if third is equal to 0. Then what we have to do, we have to say result plus equal to first plus second. And if it is not equal to 0, that means it is 1. That means any of the bit of ith bit of a or ith bit of b should be equal to 1, right? So if both are 0, if first and plus second are less than 1, that means both are 0. Then what we can do, we can say if it is the case, then simply make a 1 in our result, right? So result plus equal to 1, and here we can say return our result, right? Let's run this code as well, and I hope guys it will also get submitted, right? Because we have already successfully submitted with C++ in Java or Python, right? Now you can see that both the test case passed, so all the test case passed, so let's try to submit this code as well. And by this guys, we have successfully solved or implement our logic in C++, Java and Python programming language. And we have also understood the logic part, problem statement. If you have any kind of doubt in any of these sections, if you feel uncomfortable in logic, problem understanding or implementation part, you can write your queries in the comment box. I'm always there to help you. And if you learn something new in this video, don't forget to hit the like button and subscribe my channel. Meet you in the next video.